Alright, so where we left off with the last video, we had just compiled this code, which shows us using accessors. Alright, and when we run our program, let me put the \n's back in, just because they make it look pretty. When we run our program, everything's back to running beautifully like it did before. But we would still like to be able to change this height from being 5. So how we're going to do that is we're going to write mutators. Mutators allow us to change private data. Now, we're going to write a mutator for width and a mutator for height. When the width changes, we'll know we need to recalculate the area and perimeter. When the height changes, we know we need to recalculate the area and the perimeter. When the we're not going to write mutators for area and perimeter because we have no idea what height and width it would take to make those area and perimeters. So here we allow public access to everything by writing accessors, but I'm only going to let you change the width and the height. Area and perimeter are mine. I will adjust those as needed. You don't get full access to those. So that's how this is going to work. So we're going to write a mutator for just the width and the height. And I'm going to copy and paste this code because, like I said, it just makes life easy. Alright, a mutator is public void set, whatever variable you're trying to change, width, and you need to receive a value for it. And we always want to use the same name just because it makes sense. This dot width equals width. Right after doing that, this will change my width. I need to make an adjustment so the area and perimeter get updated as well. Otherwise, we're going to have the same problem we had before. We'll change the width, but it won't do anything to the area and the perimeter. So we need to make sure that we make those adjustments because when we change the width, the area and the perimeter need to be adjusted as well. And now we're going to write set height. And again, you'll notice I do a lot of copy and paste when I code. If I can copy, I will. Alright, so now I've done set width. I will change the width to whatever you send me, and I'll recalculate the area and perimeter. So let's go back and try to change R2. So remember, the R2 data, let's copy and paste that where it says after change again. That was pretty. Okay, R2 data after change. That way you can see what it was before to know that it actually did change. How I'm going to change it is R2.set width. Oh, we did height last time. Let's do height. Set height. And in the parentheses, we'll say 20. Saying, please change your height to 20 for me. Boom. Here is R2. 4/5/2018. Makes sense. After the change, it's 4/20/80/48, like we would expect normally, because now when we request to make the change through set height, it also recalculates the area and perimeter. Now I'm going to go back over to this file. Notice I wrote area equals width times height in 3 different points in my program. That seems a little silly. So I'm gonna, before I get into equals and toString, I first want to write a method called public void fix AP. This is for fix area and perimeter. Because I write these equations in several spots, it should be in a method. So now I'll say fix AP. So when fix AP occurs, I will recalculate the area and recalculate the perimeter. So everywhere I have area and perimeter, I'm going to call fix AP, because it doesn't make sense to have those equations rewritten everywhere. Because if I messed up one of those equations and I had it in 18 spots, I would have to go fix it in 18 spots if it was wrong. Now I have 3 locations that reference those equations. So if something were wrong with the equations or I needed to adjust them for some reason, I just have to go fix them in one spot because I have multiple references to those equations. So I'm going to compile. This all works beautifully. Just to show you, if I rerun my program, it all comes out the same. So this just makes it prettier. Alright, the next thing I want to touch base with is writing a toString method. Many times when we write objects, we want it to be able to print off in a pretty way. So I'm going to write a toString that looks almost oh, that's not a toString. Public string toString. I'm going to write a string that returns, well, I want to make a string s equals quote quote. And now all the data that normally I have to print off by saying width, hyphen, so forth, I want to print that data off from the not print. I want to return that data as text from the toString. Now I'm just being lazy. I'm copying and pasting to know what I want. S plus equals this text. And again, Control C, Control V, Control V, Control V. And here, I don't have to say get width. I'm actually in the file that has width. I just say width. I don't need to see R2. I just do height. I just need to say area. And I just need to say perimeter. But I don't want all this data to appear on the same line, so I'm going to go ahead and concatenate on \ns. If I were doing this in class, I would make the mistake and then fix it, but I don't have time to make the mistake because these videos are going to be long enough as is. So this should produce the same output that I had before. Maybe I don't want a \n here. So, alright, picking up for a pause. I'm not sure where we left off. What I'm doing, I'm saying S is an empty string, then I'm concatenating width hyphen width, next line. So I'm making this so it'll come out as 4 lines of text and displaying the same thing it did in main. But notice I don't have to, I can just say width, height, area, perimeter because I actually have those pieces of data in these files. So let me press compile. It says missing return statement. So when you write a toString, you actually have to return the text, not just make it. Return S. Now let's go back to main, and I will show you how beautiful main's going to start to look. So we had all this code. Now we say system.out.println r2.toString. Up here we're trying to print everything about r1. So r1.toString. And Control C, Control V, semicolon, semicolon. And now look how beautiful this is. This is just awesome. So, but does the program even work anymore? I hope it does. So let's press compile and play. It looks exactly the way it did before. So you're saying, R2, hey, I need a string version of yourself. Could you please give me a string version of yourself? And the string version it gives you is width, space, 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 hyphen 4. Height, space, 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 hyphen 5. So forth. It's all formatted beautifully, and we don't have to do all that code in main. We just say, hey, could you please give me a text representation of yourself? That's what toString does. Now, I want to show you something even cooler. You don't have to call the toString method. If you try to use an object as a string, it'll be like, whoa, that's crazy. But all objects can have a string version of themselves. So what it does for you, it'll automatically call the toString for you. Notice it's not compiling when it's not complaining when I compile. When I press run, boom, everything prints just awesome. Alright, now what we're going to do is we're going to talk about the equals method. Oh, I'd never showed y'all what it looked like before. Before we go into that, let me show you what it looks like if you don't write a toString method. So let's just say, oh, I just want to print my objects. It automatically calls the toString method that it wrote, which is my rectangle at 1940BFD. That's useless to us. It's the name of the class with an @ with a hexadecimal memory address after it. That's not any important information that we care about. So when we write our own toString method, we get to decide what it should print when it must turn an object into a string. And here this looks pretty. The other did not look so pretty. Alright, now that we've done that, we want to go into the equals method. So, if I do 1, 1, and I run my program, notice, oh, my constructor is off. This one's right. It does have a perimeter 4. Its perimeter is not 1. I wrote my default constructor incorrectly. Notice, it's wrong. So, again, this is why we don't want equations in lots of places, because we have to fix it. My perimeter's wrong. If you have 1 height and 1 width, you don't have 1 perimeter, you have 4. So I'm going to make some quick changes to fix this. Notice how easily I'm going to be able to fix that problem. Width, height equals area and perimeter? No, those aren't good anymore. But width and height equal 1 is great. Then all we have to do is say, you know what, I want to fix the AP because they may be wrong. Granted, the area we could have left there, but might as well do it through there. Alright, look! It's awesome! It's fixed! I fixed it with just a small little switch because I have this cool fix AP method I can call anywhere I want. So now the perimeter is actually 4 like it should be. I'm surprised I didn't notice that earlier. But once I fixed this one, I did notice it. Now let's do the equals method. Remember those memory addresses that got printed when we did the toStrings? By default, there is an equals method for objects that we've already been using. So system.out.println. I want to r1.equals r2. Notice, since we printed, they do have the same data. And when we run our program, it's going to tell us false. They are not equal to each other. They have the same data. They should be equal to each other. So we're going to talk about how to fix that. Alright, I'm going to go all the way down here. Public boolean equals, again I'm already running low on time, we have 4 minutes left, so I'm going to run through this pretty quick. Object O. The first thing you want to do is you receive an object. An object is any type of object. You need to cast it to the appropriate object. We're going to assume that whoever is calling equals is going to be sending us a rectangle. Later we'll learn how to check, but we're making the assumption now. Rectangle R equals rectangle. We're going to say, I hope you sent me a rectangle, otherwise my program's going to crash. Now we're going to run our checks. If r.getWidth equal width and r.getHeight equals height, seeing does the other guy's height equal my height? Does the other guy's width equal my width? I'm getting a knock. Hold on. Back from a knock at the door. So r1.getWidth, the other guy's width, does it equal my width? Not r1, r.getWidth. r.getHeight, does the other guy's height equal my height? If so, we return true, else return false. And now let's go test it. Cannot find symbol. What symbol can't it find? Rectangle. Ah, my class is called myRectangle. Notice I called it myRectangle because the other one turns a special color. It turns like a purple. So that means somebody else already wrote a rectangle class. So now when we run our program, we'll get true, they're equal to each other. You may wonder why I didn't compare the area and the perimeter. Because the area and perimeter will match if the height and the width match. So I didn't have to run those checks. Alright, next, 2 and 2. What I want to show you now is static. A lot of you are like, hey, what does static mean? It's hard to really understand what static means. So I'm going to put, let's just make the one value static just to see what happens. So when I say private int width, area, height, those are non-static, which means every rectangle gets their own width and their own height. But now that perimeter is static, every rectangle has to share one container for perimeter. So when I run my program, let's run the first one. In main, I create a guy that has 1, 1, 1, 4. But then when I create my second guy, he has 2, 2, 4, 8. So his perimeter is 8. But notice when I go print their data later, they both have a perimeter of 8. The reason being, there is only one perimeter object, and they have to share it. So the second rectangle changed it to 8, so that changed the first guy's rectangle to 8, because they share that container. If I were to flop the order of the code, now they would both share whatever perimeter the R1 has, because it was created second, and it changed it. So now the perimeter is 4 for everybody, because everybody shares that one single container. The only thing generally we want to make static, at least for now, is going to be the only thing we make public are variables that cannot be changed. The only thing we make static are things that everybody should share. For example, public final int number of sides equals 4. Alright, so I'm picking up where I left off last. I ran the video cut out right as I was about to say why I'm doing this. So The only time you should make something public, at least for now as a general rule, is if it cannot be changed. So if it's not public, if it's not final, it shouldn't be public. And then we go to the point of, if we make something final, do we really need 400 copies of it? So if we have public class myRectangle, if you have width, height, area, perimeter, those are not static because we found out we didn't like static that much. If you had 400 rectangles, you would have 400 widths, 400 heights, 400 perimeters. Do you really need 400 copies of number of sides are 4 for a rectangle? No, because you don't need that value 400 times. First of all, it can't even change. It's not really a variable, it's a constant. It's a constant variable, but it can't be changed. So when we make things public and final, we should also make them static. We don't need 400 copies of number of sides. We only need 1 copy of number of sides. So when we make final variables, usually we'll make them public. And we should also make them static, saying there's only one of them. We don't need multiple copies of this variable because it cannot be changed. So when we make our classes, for now, we're going to have public, static, final variables every once in a while. And all the other variables are going to be private. And usually they will not be static. Alright, that's it.